Hello everybody, I am Rakshita. Today I am going to tell you how I built the regression model for the package delivery route optimization dataset. So first I am importing all the necessary packages, then I am importing the dataset which consists of package ID, origin, destination, distance kilometer, time window start, time window end, priority and delivery status. Since this dataset does not contain any continuous numerical variables which is used to predict, so since for regression I have to predict the values, I have no column which consists of continuous numerical data. So for that I am creating a new column which I can take as the dependent column known as delivery time. I am calculating it to be a continuous numerical data by multiplying the distance kilometer into 2 and adding it to the priority. So what it does is, if the priority is high, then the time taken is low. That is the logic behind this. So then what we are doing is we are encoding the data. We are encoding origin, destination and priority. What it does is it converts it into numerical data so that it can be used for prediction. For example, now priority is given as high, medium, low. So it is converted as 0, 1, 2. 0 low, 1 is medium and 2 is high, or the other way around anyway. So we convert it into numerical data. Then we are encoding all that using label encoders. Then we have time window start and time window end. So what it does is time is taken as a string. So we are using the lambda function to convert the string into numerical data. So how it does is, if for example the time is 8:30, then it takes 8:30 and it converts it into 8.5, meaning 8:30 is 8 hours and then another 30 minutes, which is a half an hour. So it takes 8 plus 0.5, 8 hours plus 0.5 hours, by adding which you get 8.5. So that is how it converts it into numerical data. Then we have x and y. So x depicts the independent variables and y is the dependent variable. Y is the data which we are going to predict based on x. So in x we are taking all the columns except package id, as it is not really necessary to predict the data. Then delivery status, not really necessary, and delivery time. So why we are removing delivery time is, delivery time is going to be our dependent variable which we are going to predict, which we have assigned to y. Then we are splitting the data into train and test data. So xy test size is equal to 0.2. So what it does is 80% of the data is kept for training and 20% of the data is kept for test, and the test size is 0.2, meaning 20% of the data. Then we are scaling the data. So what scalar does is, basically it transforms the data, the numerical data, so that they are close in number, meaning they do not have a very large range. So this reduces chance of outliers. So that is why we are using a standard scalar to uh, scale the train and test, x train and x test data. Then we are building a random forest regressor and assigning it to the variable model. Then we are fitting the x train and y train into the model. So now the model is created, and then we are going to predict the values using model.predict function. So we are predicting the x test data. So this is the predicted values. Then the metrics that we generally use for regression are mean absolute error, mean square error, and R2 score or R squared score. So we are calculating all that using the test and y predict values. So test the similarities between how close the test values are to the predicted values. So test that and gives you the values. So this is the report we make for regression. Thank you.